Solve the first order linear differential equation x into first derivative of y with respect to x plus y, that is equal to x cube plus x, by the method of integrating factor. And this given equation is a first order linear differential equation, and we have to find the solution using integrating factors. The theory of the integrating factor, how you can find out or how you can solve the first order linear differential equation using integrating factor, I have explained in the theory in the previous video. So watch the previous video. So the given equation is x into dy by dx, or derivative of y with respect to x plus y, that is equal to x cube plus x. So you simplify it, you divide x on both the sides. So if you divide in the numerator, in the left hand side, this will be equal to the first derivative of y with respect to x plus y divided by x, and the right hand side, if you divide x, then this will be equal to x square plus 1. Suppose this is equation 1, and we know the general form of the first order differential equation is given by derivative of y with respect to x plus py, that is equal to q. Suppose this is equation number 2, and if you compare equation 1 and 2, then p will be equal to 1 by x and q will be equal to x square plus 1. So the integrating factor, as you have defined in the, or as I have explained in the previous video about integrating factor, you watch the previous video to know about the integrating factor. So we know the integrating factor, you have to remember this formula. The integrating factor is given by the formula e to the power integration p dx, and here p equal to 1 by x, so e to the power integration 1 by x dx, and we know integration of 1 by x dx is equal to log x, so e to the power log x and e to the power log x to the base e, so that will be equal to x. And we know the solution of the first order linear differential equation in terms of integrating factor. This is the solution, and how you will find out the solution, you watch the previous video. You have to remember this formula for the solution using integrating factor. The solution is given by the formula y into integrating factor, that is equal to integration of q into integrating factor into dx plus c. You have to remember this formula, and also you have to remember the formula for the integrating factor. So here integrating factor is equal to x, so y into x, because integrating factor is equal to x, that is equal to integration of q you have find out here x square plus 1, so x square plus 1 integrating factor is x into dx plus c. So the integration of, you multiply x square plus 1 with x, this will be equal to x cube plus x into dx plus c. So if you find out the integration of x cube dx, that will be equal to x4 divided by 4, and the integration of x dx, this will be equal to x square by 2 plus c. So yx will be equal to x4 divided by 4 plus x square divided by 2 plus c. So y value will be equal to x cube divided by 4, because if you divide the right hand side with x, this will be equal to x cube divided by 4 plus x by 2 plus c by x. So this will be the required solution for the given first order linear differential equation using integrating factor. Thank you.